Hello students, welcome back. Now we are going to talk about a new sensor called temperature sensor. Temperature is very important environmental parameter, and here we are going to use a sensor which will convert these temperature values in degree Celsius into electrical signals. LM35 is one of the most commonly used sensor in projects as well as appliances and industrial applications. It's a very small sensor and very easy to use. This sensor converts every degree Celsius change in the temperature into a 10 millivolt change in the output signal. So here we have three pins. One is for ground, one is for VCC, and VCC can be 4 to 20 volts. So that means it can work on a wide variety of applications. And the third pin here, that means the central pin, is our output. So with every degree change in the temperature, we are going to see a different answer in terms of voltage value. Now, how do we use this sensor? We are going to test on Tinkercad now. So in the Tinkercad library, when we scroll down, we can see a temperature sensor here, or we can simply write the temperature here. So here we have sensor as well as a starter for the sensor. So you can take any one of them. I am taking actually both of them to see what are these. So when I scroll up this sensor, there is a power pin, V out and ground. And what is this starter pack? Here we are having 3-volt battery. Power is connected to positive, ground is connected to the negative, and the central pin, which is V out, is going to a multimeter which is in voltage mode. So I'm going to start the simulation now, and we can see when I click on this temperature sensor, the current value is 25 degrees Celsius and it is giving 749 millivolt. If I increase it towards higher side, the voltage output is increasing, and if I go till the maximum, this is the maximum voltage, and on the minimum side we can see this is the minimum output. So a 3-volt input means the total battery is 3 volt. The temperature sensor is giving me the range of 99 millivolt to around 1.75 volts. So we can use it with 5 volt also. Ideally we should use between 4 to 20 volts. So let us connect a simple circuit now. Let me delete all of these. I may not need them. And let us take one Arduino board now. And I'm going to take one buzzer. So in the buzzer also we have two terminals, positive and negative. Here we have a sensor. So let me connect now. Power is going to go to the 5 volt. This will be in the red color because we are giving VCC. Then ground will be connected to ground with a black color wire. Okay, now output, it's an analog output, so it should be connected to one of the analog pins, not on the digital pin. So this is something that you should be careful about. Coming to the buzzer, the ground should be connected to the negative. I connect the ground to the negative with a black color wire, and positive can be connected to any of the digital pins. So I am connecting to pin number 12 in this case. What will be the program? So here I say I will use simple if else, and I am going to read my analog pin and I am going to compare the value. So if the analog pin value at A3 is less than, less values will be reflecting lower temperature, more values will be reflecting higher temperature. So if I say if it is greater than 200, this value is from 0 to 1023. So I am taking somewhere on the lower side. If it is there, then I don't need the LEDs. Go to the output, set pin number. Where is my buzzer connected? Buzzer is at 12. Pin number 12 to high. Otherwise, set pin number 12 to low. So if it is low temperature, buzzer will not blow. If it is high temperature, the buzzer is going to sound. So coming to the text part, it is very simple. I have two pins. A3 is input, 12 is output. Analog read A3, if it is greater than 200, then digital write 12 as high, else digital write 12 as low. There is one thing which I missed in the block coding. I did not put any delay. So the text part has already included a delay element, because without delay the circuits will not work properly. So always remember to insert some delays. So here we should make an habit that you should bring some delay after these operations. So now you can see that 10 millisecond delay is not given. So let me hide the code and we run the simulation. So here the temperature is on the lower side. If I increase this temperature, so you could see that the buzzer was giving sound on the higher temperature. So this can be like if you have a surface or a room and the temperature rises, then an alarm can be triggered. So that was an interesting application with temperature sensor. We are going to talk about gas sensors and how to use it in the next video. Thank you.